how to select and integrate the right antenna for your application. Where do we start? First, we need to identify a few things at the very beginning. What is the use case? What is the application? How's it going to be used? What will be the orientation? How will it be mounted? What is the very best position for the antenna or the antennas on your PCB or within the enclosure? You must identify the proper PCB size for the antenna, the form factor for optimum performance. You need to identify the polarization. What is the key or the best polarization for the application? Where would you like to have peak gain, radiation pattern for the best performance? Required performance. What frequency bands? What wireless carriers? What subcategory classification, especially in cellular? And proper ground plane design. Please understand that the antenna has a symbiotic relationship with the host PCB. Selecting and integrating the right antenna. Be aware of surrounding materials, heat sinks, batteries, all sorts of metal parts and wires and cables and ribbon cables. Multi-stack PCBs. Be aware that for proper antenna performance, we recommend 4 layers or more. Be aware of other antennas. Be aware of, as I said, batteries and displays, metal enclosures, metal parts, wires and cables, as I mentioned. And also understand that you will need a pi network, which is a tuning circuit between the antenna, down the transmission line, to the modem or the receiver. Antenna location on a PCB, very important. Important things to know. Antennas must have, I should say, a preferred optimal position, orientation, and with this orientation you'll get the optimum radiation pattern for your application. Ensure the chosen location can accommodate the type of antenna used. Review the design rules. They're always available in the data sheets. Remember clearance area, very important. Do not block the radiation pattern of the antenna. Surface mount antennas are dependent on the host PCB. I can't stress that enough. As such, a host PCB shape and size will influence the antenna performance. Here's 2 examples. To my right, you have there a planar inverted F antenna, an on-ground antenna, which is a very good type of antenna structure for GPS. Why? Because it has very good performance, very peak gain, pointing towards the sky. An omnidirectional radiation pattern, such as this radiation pattern, is ideal for Wi-Fi LTE applications. Why? Because it has a hemispherical radiation pattern, a fairly regular gain throughout 360 degrees.